I'd like to introduce our next speaker, Ryan Clement. Ryan is a preclinical studies leader as well as a research engineer from Actuated Medical. And the title of his presentation today is The Use of a Vibrating Needle During Venipuncture Reduces Insertion Force and Yields Lower and Less Variable Average Corticosterone Levels in Rodents.
Great. Thank you all for hanging around for this last talk of this session. And I'd also like to say that I'm with Actuated Medical. We're a small medical device, a startup company in central Pennsylvania, located in Bellefonte. And this is actually our first time at this meeting, and it's been very productive and worthwhile for us. I'd like to also acknowledge some collaborators on this work. Erica Unger, who was at Pennsylvania State University and was the PI on the rat studies for this work, and her colleague Sonia Cavagelli, who's now taken on in the Phase 2 project. I'd like to acknowledge support for this work was from the NIH, the Small Business Innovation Research Program, particularly the National Institute of Aging, and then this disclaimer there. The motivation for this work was to address animal research needs, as pointed out in the 2009 SBIR omnibus solicitation for the Small Business Innovation Research grants from the Division of Aging Biology that mentioned a need for minimally perturbing techniques for collecting blood in rodents, particularly in these serial longitudinal studies over the lifetime, where the process of collecting the blood can heighten the stress levels over time and affect results. And we're also appealing and attempting to address some of the 3 R's for reduction, refinement, and replacement in animal research. Obviously less stressful sampling is refinement, and if we can reduce the variability that may affect results, that could lead to less animal usage. So the basis of our approach is to explore the use of vibration of the lancet needle, appealing to the gate theory of pain. There's a number of devices on the market for using vibration to produce kind of an anesthetic effect. It's the idea that if you have a painful stimuli, if you can locate a secondary stimulus in the region where the pain is coming from, you can kind of overwhelm or mask the pain. And so we're kind of seeing if we can add that to the needle to possibly reduce the pain of the poke itself. This draws from the use of, or mosquitoes in nature actually use vibration to get their mouth parts into the body to draw the blood from their host. It helps with they have very fine mouth parts, so it helps in their penetration of the tissue. Obviously you don't usually feel being bit until afterwards. So we attempted to then develop a device, a prototype, sort of based on the picture that you show there, something that you can add disposable lancet or needle to provide the vibration and discard after use. So our prototype that we developed for doing this is an early prototype, I should say. We've gone a ways from this earlier rendition of it, but pointing out the basic components. There's a handpiece that has a motor located inside of it that provides oscillatory motion to a coupler on the front that we can then attach our needle to. There's a control unit that provides the power to the motor, and the displacement is about half a millimeter peak to peak. We then hypothesized that using this vibrating needle that we could reduce the insertion force, hopefully greater than 50%, and that this would then lead to a less stressful or less corticosterone release in the blood samples that we got. And that was then evaluated in a serial blood sampling study in Sprague-Dawley rats. just to address the insertion force issue, highlighting our basic setup here. I apologize, I am an engineer, and so I like to show the engineering, the test setup. It employed a force sensor that we would couple our rat tail. These are cadaver rat tail segments that we obtained from Penn State for doing the insertions testing. That coupled to the force gauge, and we recorded the forces with the data acquisition system. We could also monitor things like the power to the transducer and the displacement for device optimization. And next slide here shows some results that we would show the difference between vibration of the needle and non-vibrating insertion. Non-vibrating is in red. In that, oops, sorry. The basic, this is where the tissue is contacted. It rises up in force and ends up puncture as you get through the rat tail skin. And then once you're through, then there's a pull out. So there's a negative force then recorded on the force gauge as the needle comes out, which is obviously primarily due to the friction as you pull out the needle. And by vibrating, we can reduce that peak force as well as the friction force of pulling out of the needle after you've made the poke to cause the bleed. And in green there is the vibration amplitude, showing that it's pretty stable over the time of the insertion. Here's a summary of the results, showing the peak insertion force differences that we get along the length of the different positions where the rat tail segments were taken from different positions of the tail. And showing that at all those positions, the force being less. And if you look at it on an average, it's about 68% or close to 70% force reduction in the force to puncture the skin and to puncture the skin. So we achieved our force reduction that we were looking for. So we went ahead then and did a rat tail blood sampling study in Sprague-Dawley rats. This was a IACUC-approved protocol conducted at the Penn State University Department of Nutritional Sciences, PI Erica Unger, where we basically took a group of 20 rats, split between a treatment group where all the venipunctures were performed with the device being turned on and providing that oscillatory or vibration during the insertion, and then a control group where we just poked like standard without any needle vibration. Basic protocol is we spread it over 3 weeks, or it was a 3-week study. On day one, we sampled 3 different times at an hour interval between each sample, and then repeated a week later, obtaining, or at least attempting to obtain 3 additional samples, and then repeated again in a 3rd week. During all that time, there was no crossover of the groups. They were always either getting their venipunctures with the device on or with the device off. The basic procedure for obtaining the blood sample involved a assistant that held the animal, and then the device would go in, make the puncture, and then we collected the blood in a capillary tube. We measured corticosterone concentration with the radioimmunoassay, and also recorded a number of attempts attained to poke in order to get enough blood that we needed for doing the assay. Measured vocalization movement through a video analysis by a panel of reviewers that scored it 1 through 5. This is a summary results of the corticosterone concentrations that we saw, and it was sort of a growing difference in the first week. It was just basically not different, but by week 3, the average corticosterone detected in the blood was about 65% less in the on group, and those results at week 2 and 3 were statistically significant. We also can look at, rather than just looking at the overall average from each group, this one looks at it by taking a comparison to each individual's initial starting baseline from the first sample, because there could be some just baseline differences, and then we track the shift from baseline in each animal, average the shifts over time, and again we can see that the corticosterone level was a bit more stable and lower, particularly in the later weeks with more samples. The standard deviations were also less if you took each individual 9 cohort samples or 9 blood samples could potentially have been obtained from each subject. If you looked at the standard deviation, is about 40% less in the on group, and that was a p-value of 0.08, so it wasn't quite as significant, but there was a difference observed. This is actually one of my favorite slides. This is if you take each look at the cage mate. So they were housed in pairs, and with one of the pairs receiving the venipunctures with the device turned on, and the other pair with the pair with the device turned off. And in each cage, if you looked at a cage by cage basis, on average the corticosterone was less for that subject. And if you looked at the pair difference throughout, on an average, was about 33% less for the on group. The behavioral analysis, the video analysis, also kind of backed up those stress hormone results, suggesting less movement and vocalization following the punctures. We've had a group of veterinarians, researchers, technicians evaluate it and believe there's some value for the device, and strongly agree that the force reduction was significant. And we've also got a lot of great feedback here. We have a booth, and we've had people coming by and trying out the device and giving us good comments as well, which we appreciate. So in summary, we were able to see a force reduction up to 60% in the rat tail in vitro testing, bench testing we did. We saw less stress hormone with punctures obtained or performed with the device being turned on and providing vibration, less variability, and also less vocalization and movement to those punctures. So in general, we can supports the reduction refinement in animal studies. And we have ongoing work. I'm just kind of running out of time. You can summarize it there. We are looking at trying this in mice and doing looking at different locations, submandibular vein bleeds, saphenous, and tail pokes as well. And we've gone from that prototype to actually having a device that we're going to be ready for launch in January 2014. And if you'd like to see it, we have our booth. We'll be taking down at about 1 o'clock today, but please come by and test it out. I'd also like to thank Nancy Dadon, our program officer on this project, for support, as well as the National Institutes on Aging, NIH, and of course for your time. And I'd take any questions.
Any questions for Ryan?
Yes.
Were there any differences in the volume of blood collected?
There were some differences. We weren't quantifying it as much in this study. We've now in the mouse follow-up studies we've been doing, which I didn't include here. We're finding it's not terribly significant, but what we were seeing is the number of pokes required. We have a higher incidence of only needing one to get the blood, rather than having to sometimes you have to go twice or 3 times to get the blood from the tail. More often it was just requiring one with the on group. Yeah.
I'm not sure you mentioned it. Could you explain how the rats were handled?
Yes, the way we did it, I forgot to mention too, kind of the process was they were brought into the room right at the time of sampling. There was an assistant helping the way that at least they were doing it at Penn State, is the assistant would pre-warm the tail by holding the animal in a warm water bath, and then when they were placed on the sampling platform, just using the hands to kind of keep the animal stable, and covering the eyes usually just to kind of calm them a bit more. And then the experimenter, Erica, obtaining the blood samples, would just poke the tail at that point. Thank you.